Now, before we talk about this networking scenario, what we also have is we have something called kind of a requirement and case study. So what we are doing in this session, we are trying to discuss common requirements which we have seen across different Microsoft Azure customers, because they've got offices in multiple geographic location. Instead of using one Azure region, they use multiple Azure regions. So this is just an example. So Tech Consulting has offices, and they've got offices in 3 different locations. And the locations are like Perth, which is in Australia, Seattle, and Richmond, which are 2 different locations in US. And it could be many more, right? You could have offices in Europe and Southeast Asia and different locations. Now, all the Azure resources are deployed in the Azure data centers, which are closer to those locations. So for example, if I'm in Perth, so for me, the closest Azure region is Australia East, which is in Sydney. And similarly, somebody who's in Seattle, for them, it's the West US region, and somebody who's in Richmond, for them, it's East US region. So the resources are deployed in the respective Azure regions. And all Azure resources across all locations should be able to communicate with each other. So we need some sort of a hybrid network connectivity where the resources within the different Azure data center, they should be able to communicate with each other, which means resources deployed in Australia East, which is in Sydney, should be able to communicate with the resources deployed in Seattle Azure data center. And on top of it, the requirement is the resources from one branch, which means like physical office, which is connected with Express Route or site-to-site VPN, should also be able to access these resources, regardless of which Azure region these resources are deployed. And on top of it, it should also be able to communicate to the different branch, which is totally at different location. It's more like a branch-to-branch connectivity, and any-to-any connectivity is kind of a requirement. Now, in order to look at what Microsoft recommends, so Microsoft has got cloud adoption framework. So this is kind of a guiding principle. This is more like a Bible. So anytime if you're designing any Azure resources, there is Microsoft Cloud Adoption Framework, where Microsoft provides the landing zone design. And in the landing zone design, Microsoft have different patterns. So if you look at it here, we have got something called connectivity subscription. And in this connectivity subscriptions, we deploy the resources like, maybe we use hub and spoke architecture, we use like a VMware-based architecture, and that sits into a specific subscription. And this subscription is pretty much kind of guardrail, like nobody else should have access to this subscription. This subscription should only be accessed by the networking team who's managing this environment. So you deploy your Express Route, you deploy your site-to-site VPN, you deploy all of your services within this subscription, and this subscription has got connectivity to another subscription using the Vnet peering. So this is the Microsoft Cloud Adoption Framework, which is always recommended to be used in order to design any network configuration. And Microsoft has got design areas. So the network topology and connectivity is part of one of the design area. And that topology has got 2 different options. So when you choose the network topology, you have one option, which is pretty much like managed network, which is a virtual WAN. And we're going to talk about virtual WAN today. And the another one is like do it yourself, like traditional hub and spoke. So the difference between hub and spoke and virtual WAN is the hub and spoke is pretty much like you define what you want to connect to, which services you want to onboard, which how do you want your peering to happen. And you also need to manage it, which means you need to add a lot of steps, means configure the route tables. And on top of it, there are some limitations as well. So these are the 2 options whenever you're designing any network. The first one is the hub and spoke, as I talked about. So it's the original topology, which has been around for a very long time. Customer can manage the connectivity and security and routing. Since it's do it yourself, which means you manage the connectivity, you manage the security, and you manage the routing, which means a lot of routing tables you need to configure. It requires UDR, and sometimes it becomes quite complex if you have got multiple regions where you want to deploy your services. Now, one of the limitation of this architecture is it doesn't have a transitivity, which means I can't connect my branch locations to another branch location, because there is no transitivity. I can have a transitivity in one way, but I can't have transitivity from one, any to any. And in order to overcome some of those limitations, Microsoft introduced something called Azure Route Server. So you can deploy Azure Route Server, and it provides the BGP endpoint, and you can configure it. But still, it requires a little bit of work in order to achieve an enterprise scale networking, especially in a scenario where customers have got multiple offices, across the globe. Now, that's where we have got another option that's called as virtual WAN. So this is the another connectivity option, and this connectivity option is going to use the Microsoft Global Backbone Network. So Microsoft has got, data centers, in different geographies. It's like, more than 65 to 68 data center, which are deployed all across the globe. And Microsoft also has got the connectivity, between those data centers. So virtual WAN uses that connectivity as a backbone to communicate between multiple regions. And what it gives you is it gives you the capability to connect to different hubs. So you deploy virtual WAN and you deploy the hubs. So you deploy hubs in each region. In our scenario, if we've got like 3 different regions, so we're gonna have three hubs deployed, one hub deployed in one region like that. And that hub can have the connectivity. So it can either have the SD-WAN connectivity, it can either have the express route connectivity, it can have the site-to-site VPN connectivity, or it can have point-to-site connectivity as well. And you can basically, have this on a scale as well. So when we talk about hub and spoke, there is a limitation in terms of how many number of users can connect to point-to-site connectivity. Whereas in the vWAN, you can have like 100,000 users who can connect to point-to-site connectivity. It also uses the global traffic manager. You can have Windows or Mac operating system clients. They can also connect to your network as well. And the private connectivity for express route can scale up to 20 Gbps as well. And on top of it, if you're looking for encryption for your express route, so you can also have VPN over express route if you're choosing virtual WAN as an architecture. And if required, this whole virtual WAN architecture can also be fully secured. So there's an option of using Azure Firewall to make the hub as secure. So you can have Azure Firewall deployed on each hub, and each hub will be configured by Azure Firewall Manager, and you can have firewall policies deployed for each hub. And if required, you can also have third-party providers like Zscaler, iBoss, Checkpoint, Cisco. They can also be integrated into these, virtual hub. So Microsoft also has a partnership with the third-party provider. And if you do not want to use, Azure Firewall, you can also leverage their firewalling capabilities. And if they have a partnership with Microsoft, you can use their firewalling capabilities and secure your virtual hub. And then each virtual hub can have their respective virtual network peer to them. So let's say if I'm using Australia East as a region, and I may have hub and spoke architecture where I have, let's say, multiple virtual networks deployed for my different services, they can all peer to my hub, which means my hub will be my, gateway transit point. So all the traffic coming to my environment will be passing through my hub. And if required, I can filter all the traffic, using the Azure firewall. And on top of it, if I need to, if I need to configure any custom routes, I can also do it using the route table. But by default, one of the biggest benefit of using Azure Virtual WAN is that I don't need to worry about, configuring the UDRs. I don't need to worry about playing with my route table because it becomes quite complex as and when you add multiple regions and branch locations. So you get virtual hub router. So if you look at here, so we have got the virtual hub routers, and it provides up to 50 Gbps of throughput. It also provides the transit for express route, site-to-site VPN, and point-to-site VPN, and it also provides the automatic, automated routing. So it just provides the full, hub mesh capability, which means any resource deployed in this hub can communicate with this hub. So I can effectively have communications going like this in my environment because I'm achieving any to any kind of connectivity with the help of virtual WAN. And if required, we can deploy managed, SD-WAN solution as well. So, so if a customer is just looking for using SD-WAN solution, not looking for deploying, let's say, the express route or site-to-site VPN, they can also integrate it with the SD-WAN, or they can have a mix of, both as part of this solution. Now, this is an example of our target architecture. So as we talked about, we've got, different offices. And this is kind of a very common scenario we have seen across our customer landscape, where customers have got offices all across the globe. Just for the simplicity, we have not put together a lot of different locations, but yes, this solution can scale. Now, in this environment, what we see is we have got something called, on-premises. So this is like my on-premises environment, and I've got a VM running here, and this is connected to my express route, and this is connected to my virtual hub, and I should now be able to communicate to the VMs deployed across the spoke network in another virtual hub, as well as resources if they are deployed in any branch as well. So this gives me a fully matched, transitive routing, configurations to communicate from one branch to another branch, from one branch to another virtual network, deployed in the local hub, which is here, or the hub which are, connected with my hub as well. So this is the benefit of this architecture, that I can have this connectivity end to end. And if I want to secure this connectivity, I can also have Azure firewall. And if required, I can also filter my traffic in case if I don't want that, the specific traffic to be routing. I can also configure if I do not want to enable my connectivity to the branch location. So if required, I can disable it. That option I have as part of the configuration. And in case if you guys have any questions, please feel free to put it in the chat window, and we'll be happy to answer your questions during the session. With this, let me just jump onto my demo and show you how does this vWAN experience look like. So, all right. So in order to get started for vWAN, the first thing we need to do is log into Azure portal and look for Azure Virtual WAN. And for Azure Virtual WAN, we simply just come here and create the virtual WAN. So the experience is pretty straightforward. You know, it's just like any other Azure service. You select the subscription, you select the resource group, you select where you want to deploy your Azure Virtual WAN. Just be mindful of the fact that it only deploys the metadata, because Azure Virtual WAN has got a concept of hub, and each hub should be deployed in each Azure region. We will see it in a minute how that experience looks like, but here in this location, it's only saving the metadata. So maybe I'll just call it. And I have two choices, standard versus basic. Now I will select standard and click create. The difference between standard and basic is the basic doesn't give you the capability to connect any to any. And at the same time, the basic doesn't provide you the capability to leverage the express route. So if you're looking for leveraging the express route, you would always need to go with the standard one. And on top of it, basic also doesn't support the security features like Azure Firewall. So if you want to utilize any to any architecture, if you want to leverage Azure Firewall and express route connectivity, you would always need to select standard. Now, once the vWAN is created. So it's pretty much like you've got the metadata. And now the next step, what you will need to do is you would need to configure the hubs. And the way we deploy hub, so think it more like we are doing hub and spoke architecture and we are creating the hub. Now, in this scenario, the hubs are managed hub. So if you have gone through the experience of deploying the hub and spoke architecture, you basically configure your virtual network, you configure your express route gateway, you configure your express route circuit. So you have to do a whole lot of things. But here, everything is kind of based on the wizard. So I would just quickly show you this because I already have everything configured. So don't want to waste the time because if I select Express Route Gateway, it's going to take 40 to 45 minutes. And that's not what we want to do in this session. But just to give you the perspective, for deployment of a hub, we need the informations like which region we want to deploy. So take an example. I may want to choose different regions. Maybe I can choose East US2. I can give a name of the hub, maybe East US2 hub. And I also need to provide the hub private address range. Now, this is something what it will do. It will basically deploy a virtual network. And I won't be able to manage that virtual network because it is Microsoft managed. And this virtual network would, would be managed by the Microsoft. So, we won't be able to leverage that one. So it's a good idea to give at least /24. So maybe if I want to give, I can provide that IP address range and I can provide the hub capacity as well. Maybe I want, specific router with how many VMs we want to support, things like that I can provide. Now, once I do it, I can go with site-to-site VPN, point-to-site VPN, express route. And if I say yes, what it will do, it will ask me the questions. What's going to be the scale unit of your express route gateway? So based on what's the scale unit required, you can select it, and it will deploy a gateway, under the hood. So this would do all these things for you instead of you are managing and creating and configuring everything by yourself. So this is how the virtual hub experience looks like. I will just cancel it because don't want to configure this because it's going to take time. Instead of that, I'm going to look at my existing hub. So I have got this hub deployed, or I would say like vWAN deployed. And within this vWAN, I have got 3 different hubs deployed. So as I talked about, I come to the hub, and this gives me the view of what my hubs are. So I have configured a different address space. Just for simplicity, I've got 3 different private IP address ranges, which I've used for 3 different regions altogether. And this gives me the view, like one of my hub has got the express route connected. And, and I have got, these 3 hubs in 3 different locations. Now, if I need to manage my hub, I can simply click on the hub and I can manage it. And if I need to, let's say, create a Vnet connection. Now, in a scenario, if you are trying to achieve hub and spoke architecture, so think it in this way. If I've got a virtual network, so until now, what I've done, I have created hub number 1, hub number 2, hub number 3. So I deployed these 3 hubs. Now, these 3 hubs will allow my network to communicate with each other. But in order to deploy any workload, I would also need to deploy something called virtual networks. Means I will have my landing zone subscriptions. So when we talk about the cloud adoption framework landing zone design, you have a connectivity subscription. So think it in this way. This is more like a connectivity subscription where we have deployed services related to the connectivity. But on top of it, we will also require landing zone subscription, which means I will have something like my landing zone for, let's say, Azure Virtual Desktop, landing zone for my database subscriptions, landing zone for my Kubernetes subscription, and all those subscriptions would have their virtual network. Now, in order to leverage this global architecture, I would also need to, allow that communication to happen, which means it's more like, I'm just now peering to my hub. I can't manage the hub. I can manage these virtual network, and I can create the, peering. So if I go back and if I look at my virtual network connection, so I could see I've got virtual network connected. So these two hubs have got one virtual network connected. And I could have like multiple virtual network because in some scenarios, I may be having, 50 subscriptions and I may have 50 virtual networks connected to a single hub, or, it could be more as well. Now, you could see I've got one hub which doesn't have any virtual network connected. Now, I would connect a new virtual network, and the way the experience looks like, because hub is deployed, the next step is you need to add the connections. So if you got multiple virtual network, you need to repeat this, configuration. So now what I'm going to do, I will, configure my Vnet peering for my West US virtual network. So I'll give it a name. Um, we have we have is the name of the hub, and Vnet is the name of my virtual network. And I will select to which hub I want it to be connected. Now, since it's West US, I'm connecting it to the West US network. West US hub, and I will select my default resource group where where I have created all these resources. And I'm also going to connect to my virtual network in West US2. So I'm going to use my West US2 virtual network, and I will select these routing configuration. So the one thing what I'll have to do whenever I'm configuring these connection, I would need to make sure I select propagate to none. So I can select propagate to none as yes in case if I want to, let's say, isolate my network and I don't want it to be communicating for any global communication. So it means it's just pretty much like a black hole I'm trying to create, which is not my requirement, because in my scenario, what I want to do, I want to have my branch to branch communications. I want to have my virtual networks to communicate with each other. Now, while I'm doing this, I would also show you how this would look like in the experience perspective. So just to just to go back like my demo environment, I have my hubs connected. Like in my environment, I've got my two hubs connected, but I don't have my third hub connected. So my West US network is using 192 series network, and I will ping it and it says the request timed out because I don't have this global connectivity. So in this scenario, I have got this hub and the VM sitting in here is connected with this hub and the VM sitting here. So this kind of a connections I have done, but connection from here to here is not done. So the way I will do is, maybe first I'll show you the ping. If I ping, yep, I'm able to communicate. So one of my ping is working because I've got two hubs connected and both the hubs have got their virtual network connected with themselves. So that's all done. Now, once I configure this, and if I select my associate route table, which is pretty much like, do I want to associate to the existing route table? And do I want to, propagate my routes to a route table? So what I'm trying to do here is I am pretty much receiving the routes from the route table, and I'm also propagating my routes to the route table because I want to have that kind of a communication. In a scenario, if you want to avoid that and if you want to create like a separate environment, you might want to choose none, or you can also create a custom route table and associate with that route table. And this is something which can be changed at a later point of time as well. If you want to manage it through the labels, you can also create the labels and associate and propagate the routes to a label as well. Now I'll click on create, and what this would do, this would now connect to my West US virtual hub. So the virtual network in this example, which I have here, is now getting connected to my virtual hub because as of now, this virtual network is completely isolated and it has no communications to anybody. And since I have got this configuration setup. I already have this and this talking. Now, once my connection is completed, I should be able to communicate with 192.168.1.4. So I'll go back and yeah, so it takes a few minutes. I may come back to this one to see once it's completed. But yes, once it's done, I would be able to ping to my virtual networks deployed in my third hub. So while it's happening, what I'll also do is I will show you the other configuration. So if I come here and if I look at my virtual WAN hub, I have an options to disable branch-to-branch connectivity. So by default, it's enabled. And what it does is it allows my branch. And in this scenario, when I say branch, means this branch to this branch or this branch to this branch. This is kind of a global kind of a connectivity. I can disable it because by default, it's all enabled. So I can, if required, I can do that. And now I also have got the express route circuit connected. So this is my hub. This is connected with my express route, and you could see it shows the express route. Now, if I select this one, and if I look at my routing, so for each hub, I would be able to see these configuration because every hub would have its own VPN, express route, and point to site VPN. And I can also see the routing for each hub. Now, I can also see the effective route. If I click on the effective route, I should be able to see the effective routes as well. So what I'm going to do is I'm going to look at my default route table, and I want to see what IP prefixes I can connect to. So looks like my connection is established. That's why it's showing me 192.168. Now, it also shows me something called 10.150.10.0, which is my express route connection. So I have a VM which is deployed across my on-premises location, across the express route. I should be able to communicate it as well. So I could see my AS path, I could see my configuration. So I can simply see what all network can I connect. So what it shows me, I am 172.16.1.0 network because that shows it's the network, virtual network connection. Now this IP address, I can access it through my express route gateway. 192.168.1.0, I can connect it, it's my remote hub, and 10.0.1.0, it's my remote hub. So it has started receiving these routes, and if I need to, communicate to my on-prem and this new hub, which we've recently connected, which we can see it here. Yep, it's successfully added the peering, which means it's all connected. And if I go back here, and if I try to ping 192.168.1.4, I'm able to communicate because I was not able to communicate it because I didn't have that connection established. So I'm connecting from one region to another region. So the VM sitting in one of the network connected to the hub in Australia East is now able to communicate to the VM sitting in US East too. If I need to also communicate to my on-premises, because I have got a VM sitting in my on-prem, I can simply come and ping the IP address, which is 10.150.10.2. Yep, I'm able to ping it. And and you could see, that it just, it's just communicating, over the express route. It shows this TTL, like, how much time it's taking to communicate over the express route. 62 millisecond. And here it's like, 126. So this is going over the Microsoft backbone, totally across the different locations, whereas it's within the Australia East location. So this kind of showcase that with the virtual WAN in a very simplified way, we can create the virtual hub. We can connect as many virtual network we require from our region to that hub, and we keep doing it. If I need to deploy more hubs, I can simply come on the hub and create the hub, add more virtual networks, made the connection, and this would just provide me a global any to any kind of architecture. Now, if I want, I can reconfigure my hub if I need to make any changes. So let's say if I need to, upgrade my express route, maybe provide more power to my express route, I can simply select my hub, select my express route circuit, and I can configure my express route circuit. Unfortunately, in my scenario, this express route is managed in another subscriptions or in another environment, but I'm just leveraging the express route for my demo. But let's say if I want to change the gateway scale unit, I simply come here and I can change it to 4 gig, 6 gig, 8 gig based on my requirement. I can simply come and change it. So that's something which I can do it to configure my gateway. If I need to configure my routing, so let's say if I want to change the routing and don't want to communicate to the default route, and if I want to make any sudden changes to my routing, I can simply create a route table and associate it with this route table, or I can also come on my default route table and I can look at my default route table with the configurations, what's the label, what's the associations I have got. So, this is my, you know, virtual network associated with this route table, and to which route table I'm propagating my network. So yeah, if I need to make any changes, I can simply come and uncheck it. And I can even propagate routes from connection to this route table. I can say no as well. So there are a lot of configurations I can do in case if I need to change the behavior of default routing and communication. I should be able to do it in this one. And if I have got site-to-site VPN and point-to-site VPN and things like that, I should be able to manage it here. Because if I don't have it, I can simply create. And if I already have it, I should be able to see the status of those services. Now, if I go back, and if I want to see my topology, so take an example, if I've got multiple virtual hubs and, if I want to see them, how the topology looks like, I can simply click on view topology, and this would show me how my topology looks like. And this is quite useful in case if I need to look at the overall health of my network, if I need to do the troubleshooting. It shows me that I've got the virtual hub and I've got a vWAN, and this vWAN has got multiple virtual hubs. And the moment I hover over it, it just gives me some information about what's the current status. And, the green checkbox means everything is working fine. I have got one gateway, and the green checkbox means the gateway is working fine. And if it is experiencing an issue, I should be able to see it as the amber color or the red color with the red X in case, it's not connecting. And since this hub is connected to express route, it clearly shows this is the express route it's connected to. And if any of the hub is connected with, let's say, site-to-site VPN or point-to-site VPN, I would be able to see all those informations here. It's cool. That's what I wanted to cover before I hand it over to Nirmal. So feel free to post your questions in the chat if you have any.
Perfect, Deepak. Thank you. I think there were a couple of questions that I answered over chat. If there are other questions, positive, negative feedback, feel free to post it in as well. Myself and Deepak, we've worked on quite a few large implementations with Virtual WAN, happy to share any lessons learned or any questions. Yeah, feel free to post that in. Let me take that new question that was put in. So the resiliency in a single hub. So when the hubs are deployed to an availability zone aware region. So here in Australia, the Sydney region is a availability zone aware region. What we do is the backend components, the gateways, the route service, we use availability zones when we deployed. So what it means is the virtual machines that look after the underlying infrastructure gets spread across multiple zones. And also, as Deepak mentioned, typically if you look at from a best practice point of view, when you deploy your network, you would have a second region where you deployed. So we can then cross-connect the express routes and cross-connect connectivity. So even if we lose a single hub in a single region, we would still have connectivity going to a second region. So there's multiple patterns around it. Hope that answered your question around the hub resiliency, which is also a good starting point for my session. So I think the next couple of slides, my expectation is to walk you through some of the best practices and patterns, especially thinking about reliability, thinking about how we can help customers scale their connectivity to the cloud. So this pattern that I have here is a pattern we have documented in our express route, high availability, and disaster recovery documentation. So effectively what we recommend customers is from a single location, when you connect to a cloud region, you should be having two physical connections going to a connection point. And then what we also recommend is you should have a second express route circuit, ideally from a second peering point or a express route location. And then that should be going to the second region, which is what we call as a disaster recovery region. And then our guidance is to have these circuits cross-connected, which would mean that any point in failure, whether it's a component failure at an edge, or if it's gateway failure on the platform itself, you would still be able to route traffic to the second region or use the second circuit to get to the primary Azure region. So that's the guidance on the express route side of things. The other thing to consider is if express route is not the option for you and you only have a single connection, what we also suggest is to look at either a site-to-site VPN as a backup, or you would do an SD-WAN connection as a backup. So when I say backup, what it means is when the same addresses are advertised to an Azure region, and when you have your express route and VPN gateways, in the network fabric, we always prefer the express route path. So you don't have to do any special configuration on the Azure side. Naturally, we prefer the express route path. Because express route is using BGP, any failure on the express route connection, what happens is the gateway would be removing all the learn routes onto the fabric. And then any connection then would be preferring the VPN path back to on-premises. On-premises, you have to have few changes. So on the on-premises side, you could use local preferences to prefer the express route path if that's available, or you could configure local preference to prefer the VPN path if the primary express route connection is not available. So that's the option from a reliability point of view, enabling multiple circuits, making sure that the circuits are cross-connected. And then if you don't have express route circuits across two different peering points, the other option would be to look at enabling site-to-site configuration. So the third item that I will cover off is, let's say the second region or the second peering point is on a different location. So here in Australia, we have Sydney. Sydney has two peering locations, but we also have other peering locations. Like in Deepa's example, we had Perth as a location. We also have Melbourne as a location for express route connectivity. But if we have the express routes connected to Sydney and Perth at the same time, and if we don't do any route prioritization, what happens is on the Azure side, we randomly pick the express route circuit for traffic to send back. So we implement equal cost multipathing, looking at a 5-tuple hash, and then based on that, we load balance traffic between the two circuits. This is not the desirable outcome for customers because you don't want one packet reaching your Sydney region and hitting the data center with 5 milliseconds, whereas the second packet that's going to go from your Sydney region to go all the way to Perth and then come back to Sydney, which is going to add significant latency, and it's not desirable. So which means we have to really look at prioritizing the traffic. So the first thing to look at from a prioritization side of things is how do we prioritize traffic from Azure back to on-premises? And that is implemented through implementing a configuration, as we call it, the Bgp Wait values. And this is implemented on the gateway. So I will show that shortly how that's implemented on the virtual WAN. So once the wait value is set, so the highest wait will be the preferred link. So here you can see we've set the wait to be 100, which means that this is always the preferred path from region 1 to get back to Contoso location 1. The second link is less preferred, but if the primary link is not available, that would mean the Sydney location can go to Perth and then still get back to on-premises. It is higher latency, but at least we have connectivity going back to on-premises. From an on-premises side of things, what you implement is, again, very similar to the VPN scenario. You will be enabling local preference, and you'd have preference set for the primary connection going from the data center to the Sydney region, and you will have local preference set as a secondary to go via the other Perth location and then go back to the Sydney region through the second express route. So with that, what we'll do is we'll go and have a quick look at some of these configuration settings. And also I will quickly show how you can monitor some of these settings within the express route circuit as well. So if there are any outages, any failures, you would be notified when you have your metrics and the alerts set on the portal. So to get started, let me get my Azure portal. All right. So if I go back to my home page, so here we have express route circuit configured. So you would see here I have my primary and secondary connection. So I have two BGP sessions established against this circuit, and these circuits are then connected back to my customer edge router. So if I go back to my peerings, and if I look at the route table, you would see the same prefix advertised from the primary as well as from the secondary interfaces. So that's done to make this connection active. So here you will see the 150 range coming from this particular AS. So it's actually jumping through two routers. And then if I switch back to my secondary, you will see that I have the same length for AS configuration in here. So this is also jumping to through routers. So this is currently configured as active, which means traffic will go via primary and the secondary connections. That is also our best practice recommendation. However, you could prepend the AS path. So I could repeat the AS in here, which would mean that this then becomes an active standby connection, and all the traffic will be preferred through go via the primary connection. So how do we monitor or keep an eye for this? The way to do it would be under metrics. You go to your BGP availability, and this would give you insights around the BGP availability of the circuit. So example in here, you could see I've made some changes to the environment, and I had lost the BGP session during this window. The other thing I can do here you could see that this is showing 50%. And if I move over here, it's showing 100%. The reason is that initially when I configured this, I only had a single session, but later I had configured the secondary session as well. So it's showing 100% availability for BGP. But the way to know for sure is if you add splitting, you get these additional options for the metrics. So here I can go in and say, show me information by peering type. And that would show me the private peering session type that I have. Also, I can use the same dropdown and say, give me breakdown based on the peer, which would then give me primary and the secondary peer. So here, when I go in, I could see that the connection is both configured for primary and the secondary circuit, and both are active and 100% available at the moment. So if there's any failures, I could go in and set up an alert and say if the BGP session is 0 for some reason, that would mean that I've lost connectivity, and I can then trigger an alert and go investigate to find out what's going on. So quickly, let me switch back to the virtual WAN environment. So this virtual WAN environment, very similar to what Deepak was showing. Here I have an express route gateway, and I have these two circuits connected to my hub. So here what I can do is I can set the weight value per express route connection. So I can set a high value in here. So I can say I need this connection to be 100. And that would mean that if the connection, this is going to be the preferred connection for all traffic going back to on-premises. And if this connection is not available, then traffic would be going back via the secondary connection. The other thing to note on the express route circuit is that you can turn on bidirectional forward detection. We call it BFD for short. So on the Microsoft side, this is turned on by default. However, on the provider end, it is something that needs to be configured. And what that allows you to do is to bring down the detection window for a connection failure. So typically with BGP, so it could take 2 to 3 minutes for us to detect the failure. However, when you turn on BFD, within about 3 seconds, we would be able to detect the failure and then reprogram the routes. So significantly reduce the amount of time it takes you to fail over from an active connection from a failed connection to another active connection that's available. So with that, I'm going to move on to some of the patterns that we want to talk about in terms of best practices. So here, what I briefly want to touch is when you design your cloud environment, especially when you want to think about the landing zone design, first thing to look at is what are you building for? So it's really important to understand the business needs and also understand what the requirement is when you build the landing zone. And then you need to really bring a mindset where you are not designing the cloud to be very similar to how you've been using your on-premises environment with multiple VLANs, multiple segments. You need to really look at what are the cloud controls that can be utilized and build the landing zone in a way that you can consume the landing zone as effectively utility services. So you can bring in the workloads that you want to migrate, you can bring in applications that you want to migrate, or you look at new workload that you can build on the cloud, and then the landing zone that you build would support for all of these patterns that you want to build. What you don't want to do is you don't want to build the cloud just to support PaaS services or build a cloud that is just going to support only for infrastructure as a service components. Because mostly what we see is customers will always use a mix of both platform services. You might be running managed Kubernetes, and you might be running virtual machines to host your Oracle databases, virtual machines to host SQL databases. So you always use a mix of different components. You might be using Azure Backup to take backups of infrastructure. So it's really difficult to say I'm just going to have infrastructure components in this environment. The other environment I'm going to dedicate it for PaaS. It just becomes extremely difficult to scale. And most of the time we've seen with customers after 3 to 4 months, they want to go and rebuild the entire landing zone, which is again a costly exercise, and also it is not the best productive use of the time where you could be using to innovate and essentially save cost on your platform. The second one I want to cover off is when you think about application publishing, be aware that if you are using a firewall to publish web traffic, if you are not using a firewall or a device that is going to be capable of understanding layer 7 traffic, you are effectively going to lose all of the rich client information. So example, from a Azure point of view, if you are using the firewall to accept web traffic, what happens is the firewall has no context on layer 7 traffic. So it's going to accept the traffic, perform network address translation. So we'll do a source NAT, and then we send it back to the destination. So this is an anti-pattern, because rather what you should be doing is you should have an app gateway or a device that supports layer 7 traffic management in front, and then use this device to effectively get the traffic through the device, and then append the client information as X-forwarded header on the HTTP header, and then apply web application firewalling, and then you can send it to a firewall to do any layer 4 inspection, and then send it back to the application. When you send the traffic back to the application, because it's gone through the app gateway as the entry point, we preserved all the client information, part of the HTTP header, and all the rich context that's needed for the application is still preserved. The other thing to note is when we look at VPN, we have customers who look at running VPN over express route for encryption. Please be mindful when you are looking to do any kind of VPN implementations. VPN, by default, the IKE profile uses the AES encryption, which is not very efficient the way how the encryption is handled. Instead, you should be looking at implementing a custom IKE profile and utilize the GCM encryption method with AES. And this gives you the maximum available bandwidth per tunnel, which is 1.25 Gbps. But the GCM cipher is more efficient compared to the AES cipher. So with AES, we've seen you can achieve around 600 to 800 meg. But before that, you will easily max out on the packets per second limits or limits set on the gateway. So it's really not scalable unless you've looked at using the GCM encryption type. The other item is really around utilizing appliances. So again, do not bring your on-premises mindset on the way how you built your on-premises network with VLANs and multiple segmentation. Bring in your cloud thinking around governance, controls, policies, and how we can build these things within the cloud. Automatic governance, utilizing things like Azure policy without needing to have multiple NVS per zone, because as you move towards more PaaS services or cloud native tooling, it really becomes harder for you to manage the environment moving forward. The last item is with cloud, you need to really invest in building visibility, enable things like NSG flow logs, and make sure diagnostics settings are turned on for every resource, and start collecting all the logs to something like a log analytics workspace that would give you rich telemetry across what is happening on the network. When you don't collect any logs, it's very hard for you to understand what's happening on the network or even go in troubleshoot any other challenges that you have in the environment. So this is a quick view on when we talk about network monitoring, when we talk about telemetry. This is a quick example of what does it look like from a virtual WAN point of view. So this is virtual WAN, monitoring the hubs, monitoring the gateways, monitoring all the connections, monitoring express route circuit, really giving you a one-click dashboard to look at how all these things are connected, and also at the same time give you metrics around the health and give you visibility over what's happening on the network. So that's built in. You don't have to do anything. It's out of the box when you deploy virtual WAN. Outside of this, what you can also do is set up connection monitor. So connection monitor is effectively a health probe. You build a VM on the Azure environment, and then you can start either ICMP or you can use a custom TCP port and start probing an endpoint on premises, and then report back whether the connection's healthy, and also report back on things like latency on the link. So that's ongoing continuous monitoring on the network. So if there's any outage or if there's any disruption to your connectivity, you are the first to know before you get complaints or tickets raised by the application team. So it gives you a bit more of a proactive way to understand issues and also be able to apply high availability and resiliency to the network. So I think with that, I'm going to hand over to Deepak to do a quick recap. And again, thank you all for joining and taking the time to attend this session. If there are any other questions, feel free to put them in as well. But I'll quickly hand over to Deepak to do a quick recap and then wrap up the session. Thank you all.
Cool. Thanks a lot, Nirmal. I think that was wonderful demo. So thanks, guys, for joining today's session. And, just to kind of recap, we saw how Azure Virtual WAN provides any-to-any connectivity, how much streamlined and straightforward it is to communicate between multiple geographic locations where you have resources deployed in multiple Azure data centers across the globe. And at the same time, you can also connect to the branch offices from one location to another. Now, Azure VPN supports different connectivity options. So it's not just the express route. If a customer is using the SD-WAN solutions, and if Microsoft has a list of approved and supported third-party SD-WAN solution capabilities, so you can leverage that as well. But if required, you can choose any of the connectivity models. You can also use site-to-site VPN along with express route if you are looking for redundancy, where if any downtime happens for the express route and you want your traffic to be constantly working, you can either have two express route or you can also have site-to-site VPN for the redundancy. You can also have multiple express route peering locations, which can provide the high availability for the express route. Now, some of the Microsoft regions like Australia East, we've got two peering location in Sydney. They provide the high availability. So you can effectively connect to peering location in Sydney and Sydney 1, and that gives you two different entry points, which are highly available to make sure, if one express route connectivity is down, you can still connect to your environment using the different one. And we also talked about Azure Monitor. So the solution which Nirmal was showing, that's part of Azure Monitor. It provides you the end-to-end monitoring and visibility around your virtual WAN solution. You can just look at whether the resources are healthy or not. That's something you can configure in Azure Monitor. So there are by default matrices and the dashboards, which comes along with the solution. But if you're looking for deep dive logs and analytics, you can also write these logs to Azure Log Analytics, and it can provide you a complete traffic analytics information as well. Now, there are a few links around Azure Cloud Adoption Framework. So this is the first step. If you are doing anything with Azure, always go to Cloud Adoption Framework. Unfortunately, we don't have a link as a link. But yes, if you really search it on Google or Bing, you will be able to find it out. You can also have a secure computing reference architecture. So Microsoft has got the computing reference architecture for Azure Government as well. So like how governments are securing the environment, you can also have a look at it. Azure Virtualmin has got the whole documentations about different architectures and patterns and what's supported and what's not supported. How do you configure different routing policies? You can do it. And there is an option of route server as well. So if you have a traditional hub and spoke environment and you want to leverage, let's say, similar to vWAN kind of capabilities, and you want to create any-to-any kind of architecture, you can also leverage route server in the existing hub and spoke. But just be mindful of the fact that you'll have to configure Azure route server and some of the capabilities, whereas in vWAN, this all comes by default, and you can simply, deploy it within a few minutes to hours. With this, we are done with our today's session. So thanks a lot for joining our session, and you have a good day. And in case if you have any questions, please feel free to put it on the chat window. Cool. Thank you. Thanks, guys. Thank you very much.
Thank you all for your time. Cheers.